Good morning, class. We are looking at exam 3 review covering chapter 3, differentiation rules. Chapter 4, application of differentiation, covering from section 3.9 to 3.11, 4.1 to 4.5, and here section 3.10, linear approximation and differentials. So first and foremost, you have a curve y equals f of x. The point P has coordinates x comma f of x. We go a distance of delta x, and we get to the point Q on the curve with coordinates x plus delta x, f of x plus delta x. So as we move from P to Q, it gives us a run and a rise. So 3.10, differential and linear approximation. So I want you to pay attention to the graph. Definition, y equals f of x. We define dx, called the differential of x, by dx equals delta x. In other words, the run delta x and dx would be this distance bp, or this distance along the x-axis, dc. This is x plus delta x. Now this corresponds to y equals f of x. This point corresponds to y equals f of x plus delta x. And dy, called the differential of y by dy equals f prime of x dx. And I want to remind you that f prime of x is the same as dy dx. dy would be the product of the two. That is the definition. As far as graphically and what it means, if you look at the curve with 2 points P and Q, we have the run, we have the rise. The run is delta x or dx or bp. If we draw a tangent line, the run, delta x, and dx are the same. Now for the tangent line, we call the run dx. For the curve, we call it delta x. Now the rise along the curve is delta y. Along the tangent line is dy, two different things. So graphically, delta y, the rise along the curve, is f of x plus delta x minus f of x. So delta y is this distance of a bq, which means it's this distance of cq minus this distance of a dp. In other words, f of x plus delta x minus f of x. So as you can see clearly, bq is different than dy. The rise along the tangent line is dy or ab, two different things. However, we can replace delta y by dy for a function f which is a continuous and differentiable function with a small delta x. Bear in mind, delta x is blown up here out of proportion, so we can visualize dy versus delta y completely different. However, if dx or delta x is small, dy and delta y are extremely close. And we do that if delta y is difficult to evaluate. So f prime of x is dy dx, can be approximated by delta y over delta x, and delta y would be f prime of x times delta x or dx. Now, so that's the synopsis of what we've discussed. And so what happens is f of x plus delta x becomes f of x plus delta y if you move this to the left side. If delta y can be replaced by dy, then we write f of x plus delta x is almost equal to f of x plus dy. If we find the tangent line at this point, the name is linearization. So linearization refers to finding the tangent line at some point a, y minus y1 equals m times x minus x of 1. Move the y1, negative becomes positive here. Change the m to f prime of a, x of 1 to a, and y1 to f of a. So it's called L of x, f prime of a times x minus a plus f of a. In other words, do I have to memorize this formula? No, I would stick with the easy way out. Elementary algebra, point slope of a line, y minus y1 equals m times x minus x of 1. So that's the concept of a differential. Now, to make some sense out of it, let's start differentiating. ln of sine theta, as you know, with the natural log, you flip it over. So 1 over sine theta. And then times g prime, the derivative of the sine theta is cosine theta. As you know, cosine over sine is cotangent theta. What about this function? We notice we have to use the quotient rule, so we call it f over g. Therefore, f prime g minus g prime f over g squared. So f prime e to the power of x is itself times the bottom 1 plus x. Minus g prime, the derivative of the bottom is simply 1, times the top f e to the power of x, and just write the bottom and square it. So distribute, we get e to the power of x, e to the power of x times x, and minus e to the power of x. These two cancel each other. And of course, we put the x in front. So that would be y prime equals x e to the power of x over 1 plus x quantity squared. So now we are ready to find the differential of each function, meaning if they ask you to find the differential, you have to do the differentiation first anyways. Then we go back here and we say dy is f prime of x dx. In this case, dy would be times, okay, so f prime of theta d theta. So cotangent theta times d theta. In this case, because the independent variable is x, yes, it's f prime of x or y prime dx, so this thing times dx. All you have to do, multiply by dx, in this case d theta, because of the independent variable. For y equals x times 4 minus x quantity cubed, find dy, and to do so, we notice that this is going to use the product rule fg prime, and so we are going to call this f, and we call this g, and it's f prime g plus g prime f. In other words, completely ignore dy. Find f prime of x, everybody, or y prime. So it's f prime g plus g prime f. So the derivative or dy dx is 1 times g, which is 4 minus x quantity cubed, plus g prime. The derivative of this one follows the extended power rule, 3 times 4 minus x squared times the derivative of the parentheses -1 and times f, which is x. So as you can see, 4 minus x with the smaller exponent, that means 4 minus x squared is in common. You take it out. You divide this one by this one, gives you 4 minus x, and this one gives you positive 3 minus 1 and x, which means negative 3x. And these two add up to negative 4x, and we're going to factor the negative 4 out. We get x minus 1. We can put that in front. So this is dy dx, and that's not the answer to the question. However, we are almost done because dy is f prime of x dx. So dy is exactly the same thing times dx. And we're done for the first part. The second part is elementary algebra. We're going to find dy and delta y when x is 5, dx or delta x is 0.1, which simply put means for the dy plug-in, we're going to discuss the delta y in a moment, but just plug in, replace the x with 5, dx or delta x with 0.1. As we do so, this becomes 4, this becomes -1, squared becomes +1, so it has no bearing. The product of -4 and 4 is -16 times 0.1 is -1.6, and we are done. As far as delta y is concerned, delta y by definition is obviously f of x plus delta x minus f of x. We've discussed the graph also. It's very straightforward. And so just plug in. So x is 5, delta x or dx is 0.1. So f of 5.1 minus f of 5, which means into this function, replace 5.1. So 5.1 times 4 minus 5.1 cubed minus, now plug in 5. 5 times 4 minus 5 cubed. And I hope you realize this was pretty easy to calculate. No need for a calculator. You don't need a calculator here. But anyways, 4 minus 5.1 is -1.1. You can do it by hand. Cube it times 5.1. Subtract this one and you get these two numbers. The answer is -1.7881. Now, what I want to make a point of is this. These two numbers obviously are not the same, and we are not claiming that they should be the same, but they are somewhat close. Now, bear in mind, delta x or dx is way too large. The smaller the delta x or dx, in a matter of comparison to the choice of x, the closer they are. It's important to understand. So let's say it was 0.01. That would be an excellent approximation. They would be extremely close, almost identical. All right. We want to use differentials to approximate 51 squared. Well, first, I want to remind you, everybody knows how to calculate this. I think in algebra, they should have probably taught you that this can use a plus b squared equals a squared plus 2ab plus b squared, which means if you were to do it in your head, you would write 50 plus 1, so it's 50 squared plus 2 times 50 times 1 plus 1 squared. It's 2,500, 100, 1, it's 2601. So it's very easy to calculate it. But the purpose of the differential is two things. Okay, number one, if you want to use the differential, you have to come up with a function. What function do we use? All you have to do, read this and look at the operation 51 squared. What operation are we using? We are squaring some numbers, so f of x must be x squared. The next thing is you have to choose a number x close to 51 for which squaring is easy to compute. Clearly 50, because we know 50 squared is 2,500. So what is delta x or dx? The difference between the two numbers, 51 minus 50, would be delta x or dx, and it's +1. And I want to emphasize +1 because clearly what it means, when we square this one, because delta x is positive, must be larger than when we square 50 squared. On the other hand, if the question was asking, for example, for 48 squared, please understand that delta x is -2. That means 48 minus 50. So we expect 48 squared to be definitely less than 2,500. In any event, so to do so, we are going to go with f of x plus delta x, which is f of x plus dy. We have f of x and dy is missing. So we find dy by differentiating First, we get f prime of x or dy dx equals 2x, and dy is exactly the same thing times dx. Which means now we have x squared plus 2x dx. And let me erase my work. And so if you want 51 squared, okay, so those are where they come from. That means you want f of 51. That means f of 50 plus 1, which clearly indicates x is 50, delta x is 1, and plug in. So this is 2,500 plus 100 is 2,600. And as mentioned, the exact answer is 2,601. As you can see, they're extremely close. The reason why, because delta x is very small compared to the choice of x. And that's how it works. If it's small compared to that, the approximation is very good. Now, we can get exactly the same answer using linearization, and reminding you linearization as this formula, L of x equals f prime of a times x minus a plus f of a. But you don't have to memorize that. Just go with the elementary algebra. But we need to find the equation of a line by two things, a pair and the slope. So what are we looking for? We are looking to find the tangent line, we call it L of x, for f of x equals x squared at x equals 50, the number we chose. Therefore, if I plug in 50 here, obviously, I get 2,500. So the pair is 50, 2,500. What about the slope? The slope, I have to put this into f prime, 2 times x, 100. So we have both of them. We have the pair and we have the slope. Y minus y1. See, I'm not going to even memorize that. Y minus y1, y minus 2,500. This is something you should know, from elementary algebra. So y minus 2,500 equals m, which is 100 times x minus 50. This becomes 100x. This becomes minus 5,000. You move this one. So I want to make sure that everybody understands what's going on here. So we are looking at 100x here. Minus 5 with 3 zeros. Now when you move that, becomes plus 2,500. And you get y equals 100x. These two, they give us negative 2,500. If you replace the x with what you want, which is 51, you get 100 times 51 minus 2,500. And that's exactly what we got here. These two must be identical. Otherwise, we've made a mistake. And as you can see, the approximation is pretty good. I'm going to repeat the question. Use differential for a different concept to approximate square root of 27. Again, we need a function. So what function? Read the question. Square root of 27. So what operation are we discussing? Square root. So f of x must be the square root of x. Choose a number close to 27 that we can easily calculate it in our head, the square root. The closest number to that, it would be 25, because we know square root of 25 is 5. So delta x would be the difference between the two, which is positive 2. And again, you want to bear in mind that 27 is larger than 25. Delta x being positive, that indicates we may not know what square root of 27, but it's definitely larger than 5. But if, again, an example for the sake of argument, if I was interested in the square root of 24, delta x would be negative 1, because 24 minus 25 would be -1, indicating square root of 24 must be less than 5. That's the idea. So having said that, we want f of x plus delta x, which is f of x, and we have it, plus dy, we don't have it, which means we are going to differentiate this. To do so, we're going to write it as x to the power of 1/2. So f prime becomes 1/2. X to the power of 1/2 minus 1 is -1/2. As you know, this goes down, becomes positive 1/2 or square root. So f prime is 1/2 square root of x. So what is dy? The same thing, times dx. So now we put the function, we put the dy, and we want square root of 27. That means f of 27, which means f of 25 plus 2, which means this is x, and this is delta x. Plug in, replace the x with 25, and delta x with 2. Bear in mind, everybody knows 25, the square root is 5, right? So we have this one to be 5, this one to be 5. 2 and 2 cancel each other. 5 plus 1/5, or 5 and 1/5, or 5.2. Put this into a calculator. If you go with 1 decimal, they are identical. If you go with 2 decimals, 6 makes this 10, 10 becomes 0, this makes 2, and even with 2 decimals, they are identical. That's how close they are. Again, 2 compared to 25 is fairly small. That's the idea. As mentioned, we can use the tangent line. L of x equals f prime of a times x minus a plus f of a. And we're not going to memorize that. We're going to go with the easy way out, the point slope. So if you want the tangent line, what function are you using? Square root of x. What x are you using? 25. Therefore, you need a pair. You put the 25 into the original function. You get 25 comma 5, 25 comma 5 as the pair. You put it into the derivative. 1/2 times, remember this is 25 comes out as 5, 1/10. So I'm hoping nobody has any problem with those numbers. Y minus y1, which is 5, equals m1/10, x minus x of 1, which is 25. So if you distribute everybody, this gives you 1/10 times x minus 25 divided by 10 is 5/2. 25 divided by 10. We divide by 5, the top and the bottom is 5/2. And now if I move this 5 and -5/2 becomes positive 5/2. So L of x, the linearization, the tangent line has the formula 1/10x plus 5/2. Now you plug in 27 here. You get 27/10 plus 5/2. And I'm going to leave it for you to prove it's exactly 5 and 1/5, which is the same as 5.2. So please plug in 27 and convince yourself you have exactly the same answer. A similar question, we want to use differential to approximate cube root of 63.5. We need a function. And again, we're going to read the question. Cube root of, so the function is cube root of x. We are looking for the closest number to 63.5 that we can easily compute and come up with the cube root in no time in our head. Everybody knows that cube root of 64 is 4. Therefore, the answer is let x be 64. And so, therefore, we come up with dx, and now it's negative because 63.5 minus 64 is negative 0.5, indicating that we may not know what the cube root of 63.5 is, but because this is negative, it's for sure less than 4. So now f of x plus delta x is f of x plus dy. We have f of x. What is dy? Let's differentiate. To differentiate, we're going to rewrite this as x to the power of 1/3. Then it's 1/3 x to the power of 1/3 minus 1, which is negative 2/3. This goes down, becomes positive 2/3, and it becomes cube root of x to the second power. So that's f prime. What is dy? The same thing, times dx. So you're going to multiply this one by dx, meaning you can put the dx in the numerator. That's one way to write that. And so now we have f of x, we have dy, we are going to replace them again. This is your function. This is your dy. And we want the cube root of 63.5 or f of 63.5 or f of 64 plus negative 0.5, indicating x is 64. Dx or delta x is negative 0.5. So replace the x, replace the dx. As you do so, obviously this is 4. And so is this one. When you square it, you get 16. So this is 16, everybody. So 16 times 3 is 48. So we get 4 minus minus 0.5. We're going to change it to 1/2 over 48. The reason we do that, I want to make sure everybody understands why I did that. So this is 4. This plus and minus becomes negative. Instead of 0.5, I'm going to put 1/2. The denominator is 48 because this is a complex fraction, meaning 1 over 2 times 48, meaning 4 minus 1 over 96, which is 3 and 95 over 96. The reason I did that, this part, and I want you to pay attention to the fractional format. I wanted to show you I can come up with the exact answer, and you should, using fractions. Now, why am I putting it into a calculator? Because I'm going to put this into a calculator and show you how close they are. 3.9895, 3.89895, and the change starts from here. This is from the calculator. This is from our work. If you change, of course, you have to put this also into a calculator. And you're done. But I hope you recognize the reason the two numbers are extremely close, because delta x or dx is extremely small compared to the choice of x. And that's the idea. Now we're going to do the linearization on this case also, meaning, again, I'm going to go with the point slope. So I need a function. Well, the function is cube root of x. I need a pair. Well, I have the x, which is 64. And therefore, I can plug in 64 and get my pair, 64, comma 4. And I can put that into the derivative to find my slope. So one more time, 64 goes in here and gives us 4. That's 64 comma 4, the pair. If you put it here, you get 4. Square it, 16 times 3, 48, 1 over 48. So one more time, 64 goes into the function, gives you the pair. 64 goes into the f prime of x, gives you the slope. Y minus 4 equals 1 over 48 times x minus 64. And I'm going to leave it for you to finish the job. Y, also known as L of x, is 1 over 48x plus 8/3. And if you replace the x with 63.5, you will get this. And you should go with the fraction to come up with exactly the same answer. And I highly recommend you do that. It's very straightforward, everybody. The radius of a blood vessel is 1.4 millimeters. A drug causes the radius to change to 1.3. It shrinks. Use differentials to find the approximate change in the area of a cross section of the vessel. And I hope you realize that as a circle. Okay, it's a circular shape, the cross section of the vessel. Okay, very straightforward. So what's going on here? First, you have some cross section to begin with, is 1.4 to begin with. Then after the drug happens, so this is the radius, and the drug make it shrink, make it smaller, and it creates a new radius. The difference between the two is dr or delta r. So r is 1.4. dr or delta r is the difference between the two, the new minus the original one. 1.3 minus 1.4, it's negative 0.1. It shrinks. That's important to understand the sign, positive or negative. I use differential to find, so negative 0.1 and of course same units. The change in the area. So you need to know what's the area. The area is pi r squared. I hope you know the formula. So we want an approximation for this change, the shaded region. The approximation is dA. Therefore, R is 1.4 originally. dr is, or delta R is 1.3 minus 1.4 is negative 0.1, same units, millimeters. We know area of a circle is pi r squared. We want dA, which represents the approximation of the shaded region. And so to do that, first we want to go with the f prime of x, which is dy dx, and show you that same as f prime of x, we can say a prime of r. Instead of f prime of x being dy dx, a prime of r is dA dr. Because dy is the product of these two, then dA is the product of these two, and dA is a prime of r dr. And so now we want to go back to pi r squared and differentiate that to find dA dr. So a equals pi r squared, find dA dr. That means a prime of r, that means differentiation. First, notice pi is a number. So it's going to remain unchanged. All you have to do work with r squared, which is 2r. And so the answer is 2 pi r. And now dA would be 2 pi r times dr. We are going to replace the r with 1.4 and dr with negative 0.1. So r is the original r, is the initial value. And so their product is negative 0.28 pi, units of the area, millimeters squared. Can put it into a calculator with a bunch of decimals, becomes negative 0.8796 millimeters squared, which means the area of the cross section of the vessel is decreasing by this much, 0.28 pi millimeters squared. I like to write the exact answer. You have to show the work with the exact answer and then approximate it if they said so. Now, I hope you realize we can find the exact area, which is delta A, and basically is very simple. Calculate pi r squared, the area of the smaller one, pi times 1.3 squared, and then calculate the larger circle, pi r squared, pi 1.4 squared, and the difference is delta A. So I'm going to actually factor the pi out, pi 1.3 squared, pi 1.4 squared. The difference is negative 0.27 pi millimeters squared. Notice how close they are. They're pretty close because this number in an absolute value sense compared to the choice of R is very small. A bacterial colony has a population of P of T equals 20T over 10 plus T squared. In millions T hours after a nutrient is introduced, use differentials to approximate the change from T equals to T equals 2.4. So what is given? Originally T is 2. dt is the difference between the two. dt or delta t is 2.4 minus 2 or 0.4. And we want dp in essence, the change, the approximate change. So that's the first thing. Now, what is dp? I want to make sure everybody understands. Given p of a t, if you differentiate it, you call it p prime of t or dp dt. So given p of t, when you differentiate it, p prime of t or dp dt, so dp is what? The product of these two, p prime of t dt. Therefore, you have to find p prime of t first using the quotient rule. So f over g, f prime g minus g prime f over g squared. So f prime is simply 20 times the bottom g, 10 plus t squared, minus g prime, the bottom just gives you minus 2t times the top, 20t, and you put the bottom and square it, 10 plus t squared, quantity squared. Done with calculus. And so let's distribute. (200) plus 20t squared minus 40t squared. These two combine into negative 20t squared. And what is dp? dp is exactly the same thing times dt, everybody, times dt. And so we're going to plug in, we already have everything, which means we're going to replace the t with 2 and dt with 0.4. I hope you realize this 4 times 20, 80, 200 minus that is 120. 2 squared is 4, plus 10 is 14 squared, you get 196. So 120 times 0.4 divided by 196 gives you 0.245. 0.245 what? Millions of bacteria, which means times 10 to the power of 6. That means you move the decimal to the right by 6 and you get 245,000. And you say the population of the bacterial colony is increasing by 245,000. So we did the approximation. Can we find the exact? And the answer is yes, it's delta P, which means P of T, plug in 2.4, plug in 2, calculate the difference, P of 2.4 minus P of 2. When you do the math, you get 0.189. That means 189,000. One might say these two numbers, difference is huge. The approximation versus the exact. In other words, dp versus delta p. Yes, it is. Here's the reason. Take a look. dt or delta is 0.4. 0.4 is very large compared to t equals 2. That's one. But if it's 0.1 is better, 0.1. If it's 0.01, that's perfect. So that's the idea. If this number is small compared to the choice of the variable, now could be t compared to t, could be x compared to x. If this is small, you get a very good approximation. Measurement error in a manufacturing process, ball bearing must be made with a radius of 0.6 millimeters with a maximum error of plus minus 0.015 millimeters. Use differentials to estimate the maximum error in the volume of the ball bearing. So first, let's understand what's happening. These are ball bearings, and we want them to have a radius of 0.6. If it's a little bit more by this much, 0.015, it still works. If it's more than that, it gets stuck. If it's a little bit less, that means subtract this amount, it still works. If it's too much, then it's way too loose and it falls off. So this is what we want. And again, by the way, the volume of a spherical shape, we should know it's 4/3 pi r cubed. So if it's a little bit less by this much is fine. If it's a little bit more by this much is fine and it works. So R is supposed to be 0.6 millimeters. This is delta R or dr. Delta R equals dr equals plus minus 0.015. And as I mentioned, a spherical shape, see, ball bearings are in the shape of a sphere. They have a volume of 4/3 pi r cubed. So use differential to estimate the maximum error in the volume. That means find dV. So we're going to write R is 0.6 millimeters, delta R or dr is plus minus 0.015 millimeters. We know this from algebra / geometry. We are looking for dV. Okay, so given V, find dV. That's what we are looking for. And so, well, V prime of R, that means dV dr and 4/3 pi remains unchanged because it's a number. You just work with R cubed. You get 3R squared. By the way, the independent variable is R here. So you get 4 pi R squared. So the question is, what is dV? Same thing. Times dr, 4 pi R squared, times dr. So 4 pi r, that means 0.6 squared, dr parentheses plus minus 0.015. Keeping the pi, raise this to the power of 2, multiply by this one, plus minus 0.0216 pi. This is exact, everybody. Approximation, if you put it into a calculator, gives you plus minus 0.0678584 cubic millimeters. Pay attention. First of all, you have to write the units. Secondly, this is exact as we calculated. This one is an approximation, and you want to be careful with that. When you put it into a calculator, how many decimals? Just follow what they ask you. You're done. However, can we come up with the exact? And yes, we can. That's delta V. So how do you calculate that? Well, you calculate the original volume. It's supposed to be with 0.6. You plug in 0.6 and calculate the volume. Then you do it two ways. You add this, you get 0.615, put it into this one. That gives you a volume, the difference between the two. Also, you subtract this. When you subtract this from 0.6, you get 0.585, and you put it into a calculator, and you calculate it. Notice 4/3 pi, I have actually factored out. So for this one, for the larger side, 0.615 cubed minus 0.6 cubed. I hope you see that. It's 4/3 pi r cubed. So the difference between the two, I leave it for you to finish it to see the number. And on the negative side, 4/3 pi, 0.585 quantity cube minus 0.6 cube. Obviously, this becomes a positive value, right? And this becomes a negative value. And it will be close to this on the positive and the negative side, because this is fairly small compared to the choice of R. All right, for y equals f of x equals sine x, find dy. Well, never mind dy, let's find the derivative. Y prime or f prime of x is dy dx equals cosine x. So that's simple. So what is dy? Exactly the same thing, times dx. So that's dy. Find its linearization at pi over 6. Please understand it has to be in radians. It's given in radians. So to do so, we are going to find the linearization for the function y equals sine x at pi over 6. That means we want two things. We want the pair x comma sine x, and we want this slope. We want this slope. We have to put this here to find this slope. So cosine of pi over 6. That's the slope, square root of 3 over 2. So that's the slope. Now, what about the pair pi over 6 and put it in here? What is sine of pi over 6? 1/2. So x is pi over 6. Sine of pi over 6 is 1/2. So y minus y1 equals m times x minus x of 1. That means y minus 1/2 equals m square root of 3 over 2 x minus pi over 6. So this is square root of 3 over 2 times x minus square root of 3 times pi over 12. And this is plus 1/2 because you move the negative, make it positive 1/2. And you keep it as such because it's an exact answer. Y is L of x equals square root of 3 over 2 x minus square root of 3 pi over 12 plus 1/2. You want to keep it as exact, everybody. Okay. Why do we need this for? Well, part C. Approximate sine of 31 degrees. Before we move on, and I can't emphasize this enough, this must be in radians, everybody. This must be in radians. So please understand, 30 degrees means pi over 6. 31 degrees means 31 pi over 180. I'm hoping nobody has any problem with that because 1 degree is pi over 180, by the way, right? So you want sine of 31 degrees is sine of pi over 6 plus pi over 180, that 31 pi over 180 that I mentioned. And so approximation f of x plus dx is f of x plus dy, where f of x is sine x and dy is cosine x dx. So one more time, f of x is this function and dy is this. So pretty straightforward, everybody. All right, so let's plug in. Sine x, cosine x dx, sine of pi over 6, cosine of pi over 6, dx is pi over 180. So maybe I just remind everybody x and delta x or dx. Delta x is the same as dx. And so this one we know it's 1/2. This one we know is square root of 3 over 2. Let me just replace it. So we know this is 1/2. We know this is square root of 3 over 2. So you have to, at this point, put it into a calculator with a bunch of decimals, and it results in 0.5151. So that's pretty straightforward, everybody. Now, the second method, okay, so sine of 31 degrees is sine of 31 pi over 80. And if we want to use linearization, that means into this goes 31 pi over 180. That's the meaning of it. So just use linearization, plug in. So L of 31 pi over 180, as I mentioned, we have to go with the uh, radian mode. Square root of 3 over 2, 31 pi over 180 minus square root of 3, square root of 3 times pi over 12 plus 1/2. You put it into a calculator with a bunch of decimals. That's what you get, everybody. Now, if you use a calculator, as you can see, they are identical within 3 decimals, and then it starts changing here. So that's a very good approximation. So that's one way to find something like sine of 31 degrees. All right. One side of a right triangle is known to be 20 centimeters. One leg. Right. This is important. Right triangle. 20 centimeters long, and the opposite angle measures 30 degrees with a possible error of plus minus 1 degree. Use differential to estimate the error in computing the length of the hypothesis. So what is going on here? So we have the right triangle. Opposite this 30 degrees is the leg or the side, which is 20. Obviously, this is the hypotenuse opposite the 90-degree angle. We call it X. So we know one leg is 20, the opposite angle is 30 degrees, and the possible error would be d theta plus minus 1 degree or plus minus pi over 180. We are interested in finding the X. So it's important to understand what we are looking for, everybody. So one more time. Here's the right triangle. The side opposite the 30-degree angle is 20, and the hypotenuse is, we're going to call it X. Now, this angle has a possibility of an error. Could be 1 degree more or less. So plus minus 1 degree. And as I mentioned, in calculus, we always go with the radians. And so the bottom line is to figure out what's going on with this, the fact that we have 20, the relationship between those three would be sine. As you can see, sine of theta is the opposite 20 over the hypotenuse, X. So if that is the case, we can interchange X. Let me just write, X is the same as 20 over sine theta. And of course, I can write X is 20 cosecant theta. The reason we can do that, class, cosecant theta, everybody knows is 1 over sine theta. That shouldn't be a problem. So we want to differentiate. Let me just erase my work. So we want to differentiate, and remember the independent variable is theta, everybody, okay? So that's dx d theta is 20 times cosecant is negative cosecant theta, cotangent theta. Therefore, dx is the right side times d theta. And so theta is 30 degrees or pi over 6. And d theta is plus minus pi over 180. Now, sine let's write it here and then we erase it. Sine of pi over 6 is 1/2. So cosecant must be the reciprocal of that, 2. So I'm minus 20 times 2, and cotangent is a common arc square root of 3 plus minus pi over 180. And you put it into a calculator, you get plus minus 2 square root of 3 pi over 9. Again, you keep it as a product. You can simplify it, okay? Maybe I should have shown you. So 20 goes away, this becomes 9, okay? And by the way, class, minus and plus minus, it keeps it as minus plus, it doesn't matter, okay? So minus plus or plus minus 2 square root of 3 pi, exactly. Put it into a calculator, gives you plus minus 1.21. And we go back to the units, 20 centimeters, that's one side. So this must be in centimeters. And that's important to understand, okay? What is the percent error or percentage error? The relative error is dx over x. You use that and then you change it to percentage. It's really not a big deal. So to do so, let me again erase my work. So dx is minus 20, okay? So dx, let's go with that. Let's go with the exact answer, class. Dx is minus 20 times 2 square root of 3 plus minus pi over 180. Let's put that in the numerator because one, or you can even write this one, either way. But what is x? X is 20 cosecant theta. And we said cosecant theta is the reciprocal of the sine, which is 1/2 becomes 2, 20 times 2. Okay, so we're going to use this one for the numerator, and we're going to use 20 times 2 for the denominator. Okay, this is where it comes from. Let's use this color, 20 times 2, 20 times 2. So again, class, as it was mentioned, minus or plus minus square root of 3 pi over 180. This is the exact answer, everybody. This is the exact answer. Now you put it into a calculator and you get plus minus 0.03, and you change it to a percentage because they said so. Plus 0.03 is plus minus 3%. So there's a 3% relative error or relative percentage error.